Hello guys, welcome on Tesla Adventures. In this video today we are going to discuss a very important topic of this thermal expansion, which is thermal stress. And some teachers teach this topic in stress strain elasticity, but I believe that this topic should be taught in thermodynamics because it is basically the topic of thermal expansion. So we are uh, studying it in thermal expansion. So you can see that there is a rod which is clamped between two walls, and it is rigidly clamped, which means that this rod is being welded or uh, joined to this walls. The length of this rod is L0 and its coefficient of linear expansion is alpha, and gamma is the Young's modulus. Now let's suppose that if we heat this rod further, then we can see that its length will increase according to the relation L is equal to L0 1 plus alpha delta T, and therefore there would be a compressive stress which would be developed in the rod due to the pushing force of the wall. Now you can imagine that when this rod will expand, then it would push the walls away, and by the reaction of the walls, which walls would be applying on the rod in this direction, this rod would be experiencing a compressive torque, in fact compressive stress. So if we see that if these walls were not present, then what would be the expansion in the rod? Then the expansion in the rod will be delta L is equal to L naught alpha delta T. So this is the expansion in the rod when these walls were not present. Now we can see that due to the presence of these walls, we can say that this is the restricted length. The walls has restricted this length of the rod to expand. This is restricted length. So we can also assume that this wall has applied some force on the rod, and due to this force, due to this compressive stress, this rod is compressed by a distance of delta L. So strain developed in the rod will be equal to change in length upon original length L0, which is alpha delta T, you can see, and stress, compressive stress developed in the rod would be strain into Young's modulus. So we can say that compressive stress is equal to alpha gamma delta T. Now you can see that if this rod was cooled from initial temperature, then it would try to contract, and walls would not allow the rod to contract. Therefore we can say that walls are applying some pulling force on the rod, because walls are restricting this rod to contract. So this stress applied by the wall is called as tensile stress, and obviously we can say that due to the pulling force of the wall, this rod were restricted to contract, and the restricted length is the length that it would have contracted if these walls were not present. So that restricted length would be again L delta L is equal to L naught alpha delta T. Now we can again imagine that this restricted length is actually the expanded length by the tensile stress of the wall. What I mean to say, that this rod has this length, and walls have pulled this rod by a length of delta L. So the strain developed in the rod would be restricted length delta L upon L naught, and it would be alpha delta T. Okay, so the stress developed would be strain into gamma, and strain is alpha delta t and into gamma. So this tensile stress will be equal to alpha gamma delta t. Okay, now let us assume a situation in which there are two rods which are connected to each other in series and they are clamped from their other ends. So you can see that we have assumed that there is a rod of length L1 and there is another rod of length L2. This rod has a coefficient of linear expansion as alpha 1 and Young's modulus of elasticity as gamma 1, and this rod has coefficient of linear expansion as alpha 2 and Young's modulus of elasticity as gamma 2. Now what we are doing that we are increasing the temperature of this system, and we assume that if this rod was alone, then it would have expanded freely by a length of delta L1, and therefore we can say that delta L1 will be equal to L1 alpha 1 delta t, and if this red rod was alone, then it would have expanded by a length of delta L2, and therefore delta L2 will be equal to L2 alpha 2 delta t. But we know that these are combinedly joined together, and therefore there would be no independent shift in each of them. So let us assume that this joint has shifted by a distance of x towards red rod. So we can easily assume that this red rod will oppose the expansion, and therefore this x would be less than delta L1 because this green rod is not expanding freely. Okay, it is expanding against this red rod, therefore its expansion would be somewhat lesser than the free expansion length of this green rod. So now you can see that we can also assume that this green rod has expanded by a length of delta L1, but this red rod has compressed the length of this green rod by another delta x1. Okay, so restricted length for this green rod is equal to delta L1 minus x, and therefore the strain developed in this rod will be delta x1 restricted length upon original length. So we can say that it is L1 alpha 1 delta t minus x upon L1. And now stress will be equal to strain into Young's modulus. So this is L1 alpha 1 delta t minus x upon L1 into gamma 1. And now the similar analogy is for red rod. You can see that if red rod was alone, then it would have expanded by delta L2, but now its free end has moved, in fact it has moved in the backward direction. So restricted length delta x2 will be equal to this delta L2 plus x. This is delta L2 plus x. So you can see that it would be L2 alpha 2 delta t plus x divided by original length L2. In fact, this is x2, and strain developed in this rod would be restricted length upon original length. So it would be L2 alpha 2 delta t plus x divided by original length is L2. Now you can see that stress developed in the second rod will be equal to strain into Young's modulus, and this is this is L2 alpha 2 delta t plus x. Stress developed in the second rod is L2 alpha 2 delta t plus x divided by L2 and multiplied by gamma 2. And we can see that stress in these two rods will be equal because net force is 0 because they are expanding very slowly, and expansion is obviously a slow process. So we can say that the stress in these two rods will be equal, and therefore L2 alpha 2 delta t plus x into gamma 2 divided by L2 is equal to this one L1 alpha 1 delta t minus x into gamma 1 divided by L1. So dividing these two, this is alpha 2 gamma 2 delta t plus x gamma 2 by L2 is equal to alpha 1 delta t alpha 1 gamma 1 delta t and minus x gamma 1 by L1. Now you can take these Lx terms common. So this is gamma 2 by L2 plus gamma 1 by L1, and it is equal to alpha 1 gamma 1 minus alpha 2 gamma 2 into delta t, and x will be therefore equal to alpha 1 gamma 1 minus alpha 2 gamma 2 into delta t divided by gamma 1 by L1 plus gamma 2 by L2. So this is the shift in the junction. Now if there is no shift, for no shift, if shift is 0, so x will be 0, and therefore alpha 1 gamma 1 will be equal to alpha 2 gamma 2. So this is the condition for no shift. Now let us discuss the shift in the center of mass of this system. Now you can see that initially if we draw the diagram, then the initial center of mass of these two rods, let us suppose that this is origin, x is equal to 0. So the coordinates of center of mass initially, this is length L1 and this is length L2, and let us suppose that masses are m1 and m2. So initially XCOM will be equal to m1 L1 by 2 plus m2 into L1 plus L2 by 2 divided by m1 plus m2. Okay. Now this is initial position of center of mass. Finally, when they have been shifted by a distance x, like that, then we can see that this shift is x, and finally XCOM new will be equal to m1 into the new length of this rod is L1 plus x. So this is L1 plus x by 2. Okay, and the new length of this second rod is L2 minus x. So this is m2 into L2 minus x and by 2 plus L1 plus x, because we are taking the origin as this point. Okay, divided by m1 plus m2. So you can see that XCOM dash minus XCOM is the shift in center of mass, shift in COM position. So it would be, if you subtract these two, then you can see that m1 L1 by 2 and m1 L1 by 2 will be cancelled out. Here would be m1 x by 2 and m2 L2 by 2 and m2 L1 will be cancelled out. Here again it would be m2 x by 2. So you can see that this would be m1 plus m2 x2 x by 2 divided by m1 plus m2. So this is cancelled, and therefore we can say that that the new the shift in the position of COM, shift in position of COM will be equal to x by 2. Okay, where x was equal to the shift which we have already calculated, alpha 1 gamma 1 minus alpha 2 gamma 2. This is alpha 1 gamma 1 minus alpha 2 gamma 2 divided by gamma 1 by L1 plus gamma 2 by L2 multiply by delta t. So this is x, and shift in the position of center of mass is x by 2. Thank you.